So welcome to the lecture 6 of data structures and algorithms. So I have already uploaded the video, the lecture notes to the LMS. So in lecture 6, we are going to discuss stacks and queues. These are another two very important data structures. So I will give you the introduction later. So if we go back to our previous lessons, so in last 2 weeks, we were talking about the complexity analysis, right? So I hope you had gone through the notes and then if necessary, the videos. So in complexity analysis, we talked about basically how algorithms are compared based on their running time. Right? So we can compare algorithms based on several factors, but so here we are concerned on the running time. Right? So based on the running time, how to categorize algorithms. So that's what we learned there. So based on that, we learn like there are several categories. So one category is constant category. So big O1. So that is the basic like the lowest category, and then constant, and then logarithmic, and then linear, and then we talked about the combination of linear and logarithmic, n log n, and then quadratic, cubic, exponent, likewise. So I hope now you have a basic understanding on the things that we discussed last 2 weeks. But so unfortunately, you cannot just put those notes away and then get on with the next topics, and then when examination is getting closer, so you go back to those notes. So that's not possible with this. So throughout this semester and the next semester, and throughout the rest of your life, your programming life, so these concepts would be haunting, right? So you should have this understanding. If you are working as a programmer, every day you will need this knowledge, you will need these concepts, right? So that's why those are very important. Okay, so let's go to the stacks and queues. And so before that, like regarding the assignment, I told you like I upload the assignment last week, but I couldn't. So this week the assignment 2 would be uploaded, and I mean it will be shared, so you can. So I'll give maybe 2 weeks to complete that. And the other thing is, it's a reminding that your attendance would be thoroughly observed, right? So I will observe who's not participating in lectures, and then I want to check the reasons. So personally, I would call who are not participating in lectures. As I told you, if you have any problems participating, just let me know beforehand. So if you have, there are some special functions, some special situations, such cases, if you cannot, at least if you cannot send me a notification in advance, so at least just let me know why you couldn't participate in the last lecture or previous lecture. So immediately after, when it is possible, right? Right. Earliest convenience. So you have to do that. Okay. Right. So stacks and queues. Let's go to stacks and queues. So these are two data structures. Right. So stacks and queues. So under queues, we talk a special kind of queues, priority queues. Priority queue. So priority queue is the most important kind of a queue. So the use of queues is priority queues. Mainly, we concentrate on that, but basically the operations of queues are almost the same. There are few differences in when it comes to the priority queues, right? So stacks and queues. Both of these data structures are considered as secondary data structures, right? So we have like primary data structures or elementary data structures, right? For example, if we take an array, so array is a primary data structure. The reason is arrays are so we can show that in our memory. So this is an array, right? So arrays are developed or created. So we can create arrays in the memory, right? So in memory, like arrays are ordered like next to each other, right? So so array elements, right? So this is the 0th index, this is the first index, 2, likewise. So in memory, in real memory, so the things are ordered or organized in the same manner, same order, right? So array data structure can be seen in the memory physically. So physically, we can show, this is an array, right? So array is organized like this, and so, right? So physically, arrays, they exist. So that's the idea. So that's why they are called primary. So primary data structures are created without getting help of any other data structures. So primary data structures are created for themselves. Right? Primary data structures, eva apita me vena mokut පාවිච්චි කරන්නේ නැතුව හදන දේවල්. වෙන data structures වලින් හදන දේවල් නෙවෙයි. Right? So that's why they are called primary or elementary. Sometimes we call elementary. So whatever. So the idea is the same. So array is primary data. So later on, so we are going to learn linked list. So linked list are again we consider as primary data structure, right? So they are primary. So however, stacks and queues, they are not primary. They are secondary data structures. Right? So the reason is, so stacks and queues are created using other data structures. Right? So the stacks and queues, so we learn a set of concepts which can be used to organize data. In stacks and queues, we learn a set of concepts, right? Set of operations. So however, stacks and queues should be developed or created. In that case, we have to get the help of other data structures. Anit vena data structures පාවිච්චි කරලා තමයි stacks hari queues hari හදන්නේ. So because of that, they are not primary. So usually, like in our examples, we learn creating stacks and queues using arrays. So we use arrays. Also, we can use linked list. It is also possible. Using linked list, we can create stacks and queues. But in our examples, so we will go with arrays. But later on, with some examples, we can check how arrays, stacks can be created using linked list. Okay, so before getting to the details, so I just explained. So they are different from arrays. They are different from arrays. So one special difference is, so they are not primary data structures. They cannot stand by themselves. So arrays can actually. So array වලට කියන්න පුළුවන් මම array. දැන් අර කට්ටියට එහෙම කියන්න බෑ. මම array මම stack එකක් කියලා ඒකට කියන්න බෑ. ඒ කට්ටිය වෙන data structures වල උදව්වෙන් තමයි හදන්නේ. ඒ උනාට ඒකට කියන්න පුළුවන් මේ stack එක කියන්නේ මෙන්න මේ වගේ. Right. So So let's see, right? When it comes to the data structures, so we can identify these three concepts in stacks and queues, right? When it comes to, so let me remind the first lecture. So when it comes to the data structures, so we can identify some data structures as like they are representing real world they are storing real world data, right? Like arrays, right? Linked list and so on. And there are some other set of data structures. They are used as programmers tool. Programmers tool. So that means when we are doing our program in computing, so basically in computing, those data structures are used to make our job easier, or to do specific situations in computing, not just to store real world data, right? So for example, like stack is not used for storing student data, right? Suppose if I have to store your data, your marks, right? In such cases, stack won't be my choice, right? So stacks and queues, so they are mainly used as programmers tools. So we can see some examples, so then you will understand, right? So the most of the data structures store data that corresponds to real world objects or activities like arrays, linked lists, trees, and so on. However, the two data structures which are discussed here are more often used as programmers tools. More often, right? Not always. Sometimes they can also be used to deal with real world data. However, their main use is as programmers tools, right? And the other thing is both stacks and queues. So they provide restricted access. So what is that? Restricted access. So the one thing that we provide, one thing that we should provide from a data structure is the access to the data, right? So we have to provide the access to the data, like in arrays, right? In arrays case, right? So how we provide access to the array? So if we have a name, suppose our name of the array is ARR, right? So then I can access any data using index, right? So if I say like array index 3, then I can access this index item, data item. It can be accessed. So likewise, array, any data can be accessed. So all the data in the array can be accessed using this mechanism. So however, in stacks and queues, access is restricted. All the data cannot be accessed. Right? In stacks and both in stacks and queues. So I will explain how it is done. So however, in stacks and queues, we have access only to one item at a time. Other data cannot be accessed. Those are restricted. Right? And then they are abstract. So that's what I explained earlier. Like they are not primitive data type. They are abstract. Stacks, queues, and priority queues are more abstract entities than arrays and many other data storage structures. That means they are abstract, right? So what is abstract? What does that mean, abstract? So can anyone tell me what is abstract? So Fariha, what is abstract? Fariha, are you there? Yeah, so as you understand, what is abstract? So I hope you have done object-oriented programming. So you have learned abstract classes. Data is hidden here. Yeah, so Johan, that's correct. It's hidden how they store data in memory. We don't need to know how it works to store and retrieve data. Yes. So that's true, exactly. Like in general, what is abstract? So what is the meaning of this word, abstract? Like in programming and in related to data structures. So the definitions that you have given, so those are correct. But in a general, like as a general term, we can understand abstract, right? Like for example, some politicians, right? So they say like, okay, so we are going to develop the country. So we are going to develop the country, right? If they say like we are going to develop the country, it is very abstract statement, right? So then some like under that they would say like, okay, so we are going to increase the foreign investments, right? And then they would say, so we are going to increase the number of jobs, right? So likewise, so they give a lot of promises and they give a lot of abstract statements. The problem of the Sri Lankan the majority, they don't ask how you do that, right? So then they have to explain, okay, so then they struggle. Usually they struggle at that point. So those are abstract statements. They don't say how they are going to do that, right? Abstract කියලා කියන්නේ ඒක. කියන්නේ අර අපි concept එකක් විදිහට කියනවා. Right? Conceptually, so we just say something. So we are going to develop the country, right? We are going to increase the foreign investments, right? Like sometimes we need some things in abstract, right? So then later on, actually, when we are going to implement that, so then we go to the lower level and do that, right? Yeah, so it's hidden, it's hide the implementation of a particular task. So a process of filtering out. Okay, right. So information hiding, right? Those so the ideas are correct. Huh? So the abstract means like for example, like let's go to the main topic, stacks, right? Under stacks, we consider how stack should be, right? What is a stack? So we give a definition. A stack is something like this. Stack has this and stack has that, and stack can do this and that, and so on. We give just an explanation. When we talk about stacks, we don't explain how to implement that. And stack එකට මෙන්න මේ දේ කරන්න පුළුවන් දේවල් ටික අපි දෙනවා. So that's what we learn, right? The implementation can be done in different ways, right? So one can implement it with an array, one can implement with the linked list, another can implement it with the trees. I don't know, like it's your choice, right? So that's why we call them abstract. When it comes to queues, yeah, again, we give a set of operations, what queues can do. Queue එකේ මෙන්න මෙහෙම තියෙන්න ඕනේ. Queue එකට මෙන්න මේ දේවල් කරන්න. Queue should be like this, and these things can be done in queue, right? So we learn those things. So we give an abstract idea. It's just an idea, the concept. The real implementation can be done as the person who implement that, the person likes, right? So it's like if I so explain, okay, so the country should be developed like this, right? So we have to do this and that and so on. I can give just a framework, abstract framework. as most of the politicians and most of the parties do. Then taking that, for example, like one great example we have now these days, like there's a really nice idea of converting the agriculture sector, right, like the farming into so without using imported fertilizers, so instead of using them, the carbon-based fertilizers, right? So carbonic so it is a good concept, right? But it has been given as an in a very abstract level. So how to implement, how to do that? It is not included in the in that statement or wherever it was defined, right? So then politicians get into the game, and then they have done a really good job. So farmers are really worried about their crops these days. So that has happened. In some cases, abstract level explanations are necessary, but when it's going to be implemented, so then we should have a proper mechanism. Right? So that's the idea. So stacks and queues, so those are abstract concepts. Then I'm not just giving you the just concept, so I will show you with arrays how to implement these two. Right? For abstract level, you can be stacks queues ගැන කතා කරද්දී ඔය කට්ටිය කියන්න ඕනේ මෙන්න මේ stack එකේ තියෙන මෙන්න මේ ටික, queue එකේ තියෙන මෙන්න මේ ලක්ෂණ ටික. Right? If someone asks you to implement, so then you should ask, is there any preference of yours? So then if they say no, so then you can implement with whatever you like, arrays or linked list or whatever data structure. Right? So implementation is separated from the abstract conceptual level. Okay. So these are the three common features of stacks and queues. So they are used, mostly they are used as a programmer's tools, and they provide restricted access to the data that they store. And then both are abstract data structures. Right, so let's go to the stacks first, right? In stack, right? So they use a special approach, right? When you talk about stack, so this approach should be mentioned, right? LIFO, last in, first out. So that's the idea of stacks. So stacks allows access to only one data item, the last item inserted. Right? It is very easy to understand, actually. Nothing complicated here. Suppose if you have a box, right? So you put your notebooks there, right? So you have your first semester notes and your first semester programming notes. And the second semester notes likewise. So notebooks are there, right? Suppose this box is narrow, so you can put one notebook at a time, right? So this is programming notebook first semester, right? So then maybe other notebooks, maths, physics, and so on, right? So you put notebooks like this. And then suddenly in the third semester, I asked you, okay, so we are going to learn about for example, like, so we are going to learn about recursion, right? So go back to your notes in the first semester and check recursion, right? So in that case, you have to go to this, right? You have to go to this, you have to take this notebook box, and then, so you don't have access to the program. It is in the bottom. So then you have access only to the last inserted book. You don't have access to this one. You don't have access. You don't have access to all others, right? You have access only to this book, right? So the access has been restricted. Restricted to only to the last inserted, right? Last insert. So you, in that case, what you do is, so you have to remove the last inserted, right? Okay. So now you have access to the second last, right? Now this is the top one. So basically, so you can just say last inserted or top item. You have access only to this one. So you have to remove that as well. So likewise, you have to remove all the books, all these books, and then finally you can access that. So now you have access to this one. You can get the programming notebook. So basically, the last insert or the top item can be accessed. Only that item can be accessed. Only last inserted item can be accessed. For the top one, if there's just one item, so we can access that item. That's all. So the stack has this concept, right? සමහරලාට දැන් දෝසේ හදනවා කියලා හිතන්න. දැන් ගෙදර දෝසේ හැදුවොත් එහෙම මේ දෝසේ ඔහොම ගොඩ ගහලා තියෙනවා. එතකොට දෝසේ ගොඩේ උඩම තියෙන එක තමයි ගන්න පුළුවන්. යට තියෙන එකක් ගන්න ඕන නම් දැන් උඩ එකක් නෑ උඩේව නිකන් පිච්චිලා වගේ නෑ. යට එකක් නම් ගන්න ඕනේ උඩේව අයින් කරලා ගන්න. It's the same concept. It's a stack. The idea of stack is that, right? So we call them stack of books, right? Right, stack of books or stack of like pancakes here, right? So we don't eat so American type pancakes much, right? Like Sri Lankan pancakes are a little bit different, like Sri Lankan pancakes. So so you can replace this with dosa or whatever, like Sri Lankan appa whatever, right? Yes. So here this concept that is used in stack is called last in first out, LIFO. So last inserted item can be removed first. Last in first out. A stack allows access to only one data item last inserted. If the last item is removed, the next to the last item inserted can be accessed and so on. This approach is called last in first out, LIFO. So you can LIFO. Okay, so the opposite of LIFO. What is that? First in, last out. First in, last out. So what do you think about this? First in, last out. So last in, first out. First in, last out. The first inserted item would be removed last. Yeah, both are the same. Last in, first out කිව්වත් එකයි, first in, last out කිව්වත් එකයි. It is the same. Right? So when you explain the stacks, you can use both, right? You can use both, but as a standard, like usually we don't use first in, last. We use this. We go with LIFO. But the idea is the same, huh? Same concept, the same. So this capability is useful in many programming situations. So that's why, I mean, you may think why we restrict access, right? Like as programmers, right? If you are a good programmer, so you should not restrict the access, right? Like, so you may think, right? But actually, how to control the access, right? So that's the most important thing in a program, right? Like in some cases, access should be restricted. It is necessary, it is important, right? So that's why we use that. So like stack කියලා නිකන් අපිට මේ එහෙම දෙයක් තියෙනවා. එහෙනම් අපිත් මේක මේ programming වලදී අපි මේක පාවිච්චි කරමු කියලා මෙහෙම ගත් එකක් නෙවෙයි. අවශ්‍යතාවය නිසා, right? Because it is necessary in some programming situations. That's why we use that, right? So these are few examples. So few examples. Check whether parentheses, braces, and brackets are balanced in a computer program source file. Right, again, so now you should understand this is not just like regular people, something that regular people do. Check whether parentheses, braces, and brackets are balanced in a computer program source file. Computer program source file එකක මේවා balance වෙලාද කියලා බලන්න. මේ balance වෙලාද කියලා බලන්න නැහැ. මේ නිකන් ඔය සාමාන්‍ය පාර යන මිනිස්සු. මේ කට්ටියට වැඩක් නැහැ. So this is now you should understand this is a special operation which is necessary for example, like compilers. So that's why I told you. So most of these the users of stacks and queues are programmers tools, right? මේවා මේ සාමාන්‍ය data තියාගන්න පාවිච්චි කරනවට වඩා මේවා මේ දැන් compilers වලදී සමහරට මේ අපේ දැන් මොන හරි networking වලදී ඒ වගේ tool එකක් විදිහට තමයි මේක පාවිච්චි කරන්නේ. Right? This is one example. Like general, like usual programmer does not need this. It is necessary for compiler. So if you are developing, if you are creating a compiler, then it will be very essential in using stacks for this. Like especially like parsers, right? Parsers, we call that that operation parsing. In the source code is understanding the source code, right? Analyzing the source code. So in such case, use handy aid for algorithms applied to certain complex data structures, right? In some algorithms that are used in complex data structures, right? So for example, binary trees and graphs. So in graphs, we are going to learn in the next semester. In graphs, we are using stacks, right? In the graphs, so we have to go, we have to traverse the graph, right? So we have to go through all the nodes in the graph. So in such cases, stacks are used. So there are special algorithms to traverse the graphs. In some algorithms, stacks are used. So we are going to learn them in the next semester, right? Most microprocessors use stack-based architecture, right? Like I mean, so those stack-based architecture is not directly useful to regular programmers, right? So those are special cases, right? These are special cases. Parsing arithmetic expressions. Again, it is like with these users, you can identify these are, that's why I call them programmers tools, right? In microprocessors, they use stack-based architecture, right? Like I don't know whether I mentioned like in so when we call methods or functions, right? So those are stored in this manner. So we call it is called stack. So in stack, usually when we call a function, for example, the main function. So then the area. So in memory, so there are several areas, right? So one area is called stack, right? Stack memory. In stack memory, when we call a function, all data related to that function or the method, right, is stored in stack, right? So one area is reserved for that memory, that function code. So if we call a function, right, then, for example, for that function call, right, not just for that function, function call, right? We can call the same function again and again, right? For this function call, so we have a memory area, right? So then, like this function is executing. So while it is executing in that function, if another function called, right? If another function is called, then on top of that, the second function area is reserved, right? Suppose in function one, we call the function one again, like recursive manner, for example, right? Right. So then for the second function call, so we have function. Right. So likewise, so the function calls are stored in stack in this manner. So then one function call is executed, then that area is removed, right? So then the processor can access the previous function code. It will go back to the previous function, right? Then after that function is executed, so then it is removed too. So likewise, the stack data structure, that stack concept is used, right? That's one example. Huh? So likewise, we use them in many situations in so memory, microprocessors, right? And then compilers, parsers, so they used this concept a lot. Right, okay. So stacks have two main operations. Those are called push and pop. Push and pop. Push means we put something into the stack. We call push. right? We put something into the stack, right? Stack. If we remove something from the stack, remove something, I mean, something is not the suitable word there. Remove the top item. It's called pop. Remove the top item. We have access only to the top item. So in that case, removing that is called pop. Push and pop. Insert and remove. So, but we are giving special words to those. Insert and remove. So these are the main operations, very easy. So however, we can talk about some other additional operations, right? Like I will explain them, right? At the time, right? When those are introduced, right? So operations on stack, push, add a new item onto the stack and place it on the top, right? Push is not just inserting, but insert them and placed it on top, right? Push, pop, retrieve element on the top of the stack by removing it. Pop, removing it, removing it. So apart from that, like I told you, there are some other operations that we can talk about. Peek is another special operation. Peek is have a peek, have a look at the element on the top, but does not remove. Remember, does not remove. උඩින්ම තියෙන්නේ මොකක්ද කියලා බලනවා. එච්චරයි. Peek. Push, pop, peek. These are the main operations. Apart from that, we have some other minor operations we are going to learn later. Yeah. So the implementation of stack. Right. So any questions up to now? Any questions up to now? I mean, that's all. So if you know push, pop, and peek, that's it. So you know the stack. Very, very simple, very easy. So the abstract idea of a stack is that. But I told you, I'll show you how to implement that, those things. Right. So that's something like quite interesting. So we can see how it is done, how it can be implemented. Any questions? Right, so I will, so I'm going to open the Eclipse and I will, let's try to do some the implementation, right? So if you are with your computers now, right, you can try. Okay. So now, right. Okay. So here in Eclipse, I created a new, I mean, it is already there, right? So I created new class, public class tag. I created new tag. Actually, like the program was there, I removed that program. So I hope you can see the screen, huh? Right? So I'm going to create a stack. Right, so then suppose if I am going to use a stack, right, then what I need actually, stack suppose if I create a stack, right, I create a stack like this, then with that stack I create a new object, huh? So what are the operations I need, right? I can, so the stack class that I create should provide operations to insert. Yeah, so push and pop basically. Suppose if I call stack1 dot push, so then, so I can give what to insert, right? For example, if it is an integer stack, right? If I insert a value, yeah. So this value should be inserted or pushed into the stack. So I should provide that, right? So, so that's why we use interfaces. Like if you have done Java interfaces, so public interface stackable. Right? Like for example, I create stack interface for the to insert the operations of stack, right? Stackable, right? So then we need a push, and then in here, like we provide a value. Suppose we are going to create integer stack, right? So you can use any data type, no problem, right? Like in this example, I'm going to show you integer stack, how to implement an integer stack. So here we are inserting integer values. So that value should be given in push. So in pop, it will return a value. It will return a value and it will remove that value from the stack, right? Then in peak, so in peak operation, the value should be returned, but it should not be removed from the stack. Okay, so these are the operations that we need, right? So I have just added that interface. You don't have to use interface if you right. So somehow let's implement the stack class, public stack, right? Okay, so so these are the operations. So usually, like if we are using interface, so then you can implements. You can use implements right? So likewise, so you can use that, but not necessary, right? So somehow if we implement other things, so that's fine, right? Okay, so just let me copy this, right? Okay, now right, so we need to implement these methods. Okay. Right, so we can use them as public methods because we are going the access, we are giving the access to the public. Right. Right, okay. Push items, right, into the stack. Right. So this one for the top item from the stack. This one have a peek into the top item, right? Okay. So however, we need a mechanism to store these values, store these data. Here I'm going to use an array, right? I told you you can use different data structures, primary data structures. Here I'm going to use an array, right? So let's go with integer array. So in our example in the note, it is long array. So it is a long, but don't worry, the data type can be array, right? Right. You can use real data array or something, right? I'm using that name, and then I'll make this private. Right now, this can be used. This array can be used. So, however, so we have to initialize that array. Right, array has to be created. Now the variable is defined here, declared here, but we have to create the array by giving the size and no. So in object-oriented programming with Java, so we have construct. When stack is created, array can be created itself, right? So I'm going to add a construct, right? Public stack. So this is my constructor. In this constructor, I can give the size of the array. So the user, so when if I go to this class, when stack is created, we can give the size of the stack. It is we can add more flexibility, right? we can provide the size. So with that size, we can assign new image size. Okay. Now we have created an array. Right. Array stack data. Constructor. Right. Okay. Now let's use this array to insert data. So this value can be inserted. Right. Then we have to give the index. Like at the beginning, it will be 0. But however, with so we have to decide. So we need a special variable to keep the track of the size, right? So in example, right? So we are keeping the track of the top item, top items index, right? So in our implementation now, so we are using an array, right? So now we are using an array. So size can be, it is restricted size, so size can be, suppose the size is 10. And so we have 10 items. Right, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, indices are like that. Then the first item would be inserted here. Right, this is the first item. If I draw the structure as an as a stack, real stack. So the first item is here. Now we have the access to this one. So this is the top one, right? So now this is the top one. So this is the top. If I insert another item, right? The second item. Now this is the top one, right? The top one has to be this. The top. So if I want to remove item, if I want to pop, then I remove this one. So that means I can remove this side. Right. I remove top item. So then again, the previous one would become the top. Likewise, to keep the track of the top item, so we are using another variable, integer variable, to indicate the index of the top item. Right? Again, it would be private. We don't have to give its access to the outside. Right? At the beginning, when no items are there, the top item is 0 at the beginning. So in construct, I set it to 0. Top is 0. Now, when items are inserted, right, I can insert them into top. Sorry. Here, I forgot to read this. Okay, now it's fine. Okay, public void push. So, however, in this case, there's a problem. So the first one at the beginning, suppose any item is not there. At the beginning, top is here. It is pointing to the 0th index. Right? So then I the name of this one. This one. If I insert an item, right? If I insert an item here, right? Then that item is there. Now, if I insert another item, then I have to insert it here, right? Yeah. So that's so there's a bit confusion, right? Bit confusion there. So here we can do one thing. We can do one thing. Instead of using top item, we can use -1 at the beginning when there is nothing in the end. So that means top item is -1, right? -1. Suppose it is there, right? Then instead of directly inserting into top, so we can first increment the top. We can increment top, right? Top can be incremented and then do that. Or we can use this. First, we increment the top and then the value is inside. Okay, so now So let's go to just keep that as it is for now. And then let's go to pop. We have to return the top byte, right? So return this one. Top. Right? Simple as that. So, however, so if you do that, if you remove, suppose now so array name, right? Top. So we give the item, right? So this is pop, right? So we insert a value here. So now first the top would be go to 0 index and then insert. If we insert a next value first, then top would be pointing to this one. And then we insert the new value here. So likewise, so that's how we insert. When we remove, right? So then we return the top value. So this is the top value, we return that. That's all. But after returning that, after removing that, the top, this variable should be changed to point into the previous one. Right? So we have to do that as well. Right? So in that case, what we can do, we can minus. It will take the value of the top and then that value would be returned, but before returning, the top variables value would be decreased by 1. This is return. So the next one, so I'm going to copy that as well, but we are just returning the value of the top item. We are just returning the value of the top item, but we don't decrease. This value is not removed. This is the implementation. Very, very simple. So we can add some other validation checking right into these operations, but basically what this is very basic implementation of that those operations, right? So now can anyone tell me, so there's a slight difference between these two, and there's a big problem in this implementation. So what is that? Can anyone tell me? the pop and peak. Our implementation, there's a bit confusion. I mean, if you have seen that, so just let me know. Johan says array overflow. Array overflow, yeah, it's a big problem. We can deal with that later on. So before that, by just looking at this, especially by looking at the pop, there's a bit confusion there. When we peak, it is not display the expected output. It will display the element before the expected element. So Akila says, when we peak, it is not display the expected output. So why is that? Why is that, Akila? Right. So let me so I'll remove this one as well. In push, we do like this array top, then we give the value. In pop, what we do is we return and then and then in peak we return top. Okay, suppose we have now two values, two items here, and now top is there. Top is here. Yeah, let's put some values. Okay, so it is integer values. So we are putting here, suppose 12 and then 52. Okay. Akila says it will decrement the top before the peak. Suppose if I call peak, what would happen? If I call peak, it will just return this value. It will return 52. If I call peak, if I call pop, then it will return again, if it will return 52. So however, it will change the top into this. So now top is 12 because we popped the previous top, which is 52, right? But here, what is the problem? That's my question. Peak, it will display before the top value. So why is that? So that's my question. Array would So in peak, the purpose of peak is I want to check the top item. I want to check what the top item is. Top item එක මොකක්ද කියලා මට බලා ගන්න ඕනේ. So in that case, we return the array, then top index. For example, now at this situation, so if I call peak, so it will return 12. It will return 12. So nothing wrong with that. But there's another problem there. Did you notice that? The peak, no problem actually. So pop, no problem. But there is something, right? Like, okay, so if I call peak, right? If I call peak, right? So it will return 12. But still, the top item is, like it is 12. Right? But that's the purpose of peak. So we are just having a look. We are not removing the item. So nothing wrong with that. So 12 will be returned. Right? We will get 12. Right? Okay. So then so after that, right? Suppose if I call pop, then 12 would be returned, same as peak. The return value would be same as peak. So however, it will change the top value into, now the top value would be -1. Yes, sir. Like Sandun, Johan, yes, Johan. So that's correct. Like if we try to call a peak without inserting anything, it will give us an error because insert, yeah. So there is no such item called -1, right? Yeah, that's true. That's true, but I'm not talking about that one. That's a like very like bigger problem, right? Bigger problem that we have to solve. But here, I mean, did you notice something? Right? Suppose, I mean, in this picture, did you notice something? If we pop this, right? We have pop. Did you notice something? Now we have pop all 2 items from the array. අපි array එකේ තිබ්බ items දෙකම අපි අයින් කරලා තියෙනවා. දැන් top කියන එක තියෙන්නේ -1 වල. Did anyone notice something? Some unusual thing? Yeah, exactly. So even we pop the values, so those values are still there in the array. Right? So in our implementation, what we do here in pop, we return the value and we change the top items, like that index value. We decrease that. right? But still, the value that we have inserted in index 1 is still there. ඒ කියන්නේ array එකේ array එකක්නේ array එකේ item එකක් දැම්මට පස්සේ ඒක මකලා නැහැ අපි මේ. Even we says that even we say that we are removing the value, that actually we haven't removed the value. We have changed the index of the top. يعني top item එක තියෙන්නේ මෙන්න මෙතන කියලා කියන එක විතරයි අපි වෙනස් කරලා තියෙන්නේ. value එක ඇත්තටම delete කරලා නැහැ. We haven't deleted the value from the array. So, however, that's fine. That's fine with our implementation. So that's why we are calling that our real implementation is not visible to the outside. The person who's using this class don't care about how I have implemented, right? Like for example, here I create a stack from this class, right? I create a stack object, new stack. So I have to give the size. Suppose the size is 10, right? Okay, size is 10. So then I push 34. So then I can push another value. Push 56. Then push 90. Push 78. So I push values like this. And then suppose I pop. So in pop, we don't give any. So the pop means it will pop the last inserted value. So that means here it will pop 78, right? So then that value is returned. I can print that value if I want. Right? The return value would be printed. So it will print 78. So then if I call pop again, it will return 90, the top value. Right. In third case, it will be 56. Sorry, 34. Right. So let's run this program for fun. See, the output should be same. So I'm inserting 4 values and then I'm copying those 4 values. But still, as I told you, right? So let's remove these. So the values here are first 30, 34, 56, 90, 38. Right. So then at that time, the top would be here. Then I pop that, right? So if I pop, so after these 4 lines, the array would be something like this. So then I call this pop. Then the top would be moved to this one. Later, but the 78 would be returned. 78 would be returned, and then top would be moved here. Right. So in the next line, I call pop. The top index item would be returned. So that means 90 would be returned. And then top item would be decreased by 1. So now, as you have noticed, so these values are still there. These values are still there, but we don't care. You don't have to worry about that. The reason is because we are accessing the top point, right? Okay, so then if I call the pop again, this one would be returned, and then top would be moved to the previous one. Now it is the top. If I call pop again, so then it will return 34, and then top would be moved to the previous one. Then now top would be -1. Right? But still these values are there. Still these values are there. If I call a pop again, no, like let's come to that later, right? So if I call again, if I call push value, different value, like 87. If I push value 87. Now, if I push value 87, right? So first, if I call push, so then top would be increased by 1. Now top is pointing to this one. So then I will add new value 87 into this index, top index. So that means index 0, I will add 87. So 87 would be inserted here by replacing 30. Right. So now top is this one. Right? But still we have our previous value here. But we don't care. We don't have to worry because top is this one. Right. If we insert another value, then top would be pointing to this, and then with new value, this part would be replaced. Suppose we are inserting 108, right? So 108 would be added, right? So the values would be in there, but we don't have to worry because top is where we consider. The rest it's not our concern at the moment. Right. So if we remove, suppose if we call now at this point, if we call pop, it will pop this one. These values would be considered. It will pop this one and then pop would be moved to this. Right. If I call pop again, it will pop. It will return 87, and again it will decrease minus. Right. So that is how it is implemented. So we don't have to worry about removing these values. So that's how we implement. Right. Okay. So that's settled. Instead of calling pop, if we use peak, pop එක call කරන්න තෝ peak එක call කරොත් මොකද වෙන්නේ? The output would be the same. Output would be the same. What do you think? What would be the output? මේ output එකම හම්බ වෙයිද? Instead of calling peak, pop, we call peak. Peak කියන method එක call කරොත් output එක මොනවා වෙයිද? Okay, Akila, very good. Yes, this won't be the output. This won't be the output. So let's see. The output would be 78. So why is that? Because peak would return the top value, but it won't change the index of the top. Right. So now we have 4, 60, 65. Value 56. Right. So here, right now, this is the situation. Huh? This is it. So top is here. Top value would be now here. Right. අර මේ කලින් කතාව අමතක කරන්න. දැන් අපි ආපහු මේ මුලට ආවේ. දැන් values ටික තියෙන්නේ 34 56 90 78 නේ. So we have 4 values. 4 values තියෙනවා කියන එක. top කියන එක දැන් මෙතන තියෙනවා. So now if we call peak, it will return 78. And top is not decreased. So the idea of peak is not removing values. We are not removing values. We are just check what is the top value. Then again, if we call peak, it will again return 78. So still the top is 78. Because in our implementation, we return the top index value. Yes, it is the top value. Exactly. Right. So that's the difference, right? Peak means we are not removing values. Actually, even in POP, we are not removing. We are faking that removal. Remove කරනවා වගේ පෙන්නනවා හැබැයි remove කරන්නේ නැහැ. Right? ඒ කියන්නේ මේ මෙතන දැන් POP එකේදී අපි ඇත්තටම remove කරන්නේ නැහැ. අපි remove කරනවා වගේ පෙන්නනවා. හැබැයි ඒකෙන් ප්‍රශ්නයක් නැහැ remove වුණා වගේ පේනවා. We don't remove actual value. Value is still there. But later, if new values are inserted or new values are pushed, so those previous like unnecessary values would be, garbage value would be replaced. Right? So we don't have to worry. Right? But in peak, we don't remove. We don't remove. We just return the top value. Have a peak. උඩම තියෙන value එක මොකක්ද කියලා බලන එක තමයි peak එකකින් කරන්නේ. Remove කරන්නේ නැහැ. But POP, it removes. Right? The idea is removing the value. Right. Okay. Now, so let's remove. Okay. Okay. So I'm going to call POP. POP. Right. Now, so it'll right 78, 90, right? If I call a POP again, then 78, 90, 56, 34. 78 would be written here, in this case 56, 90 would be returned here, and then 70, in this case, 34. So here 90, so 90, 56, 34, right? Okay. So here, if we call POP again, it would be an error. The reason is there are only 4 values. So after removing all these values, now top is in -1. Then it will give an error, right? So without giving an error, so we have to handle that in our, it will give an exception, right? So in POP, right? So we have to check whether if top is greater than 0, less than 0, right? or we can just say if top is greater than 0 or even 0. 0 is fine, right? Greater than or equal to 0 or greater than minus 1. Then only we do this. Else we can print something, right? Message. Right? And then we can return something like it's -1 or some decided, right? Right. So we can do that. That's one way that we can handle that situation. So we can do several things like int pop value. Right. So we just pop value would be -1 if then the pop value can be assigned to this one if this is true. So otherwise pop value would be -1. So then we can return that one. That there could be different implementations of this, right? If else දාලා මේක කරන්නත් පුළුවන් නැත්නම් මේ වගේ එකක් කරන්න. Else so we can just we can just print there are no items to be right. So if we do that now, let's see. Right, so the values would be printed. There are no items to be popped. Then -1 would be printed. So this -1, it can be decided by you, right? You can decide what is to be returned. So in this case, these are values like integers. So we can have object stack. So then the type would be object type. So in that case, we can return null value, right? So this is just one implementation. You can come up with different implementations, right? So the message has been given here, right? There are no items to be popped. So that's the end of the, like when this popped item is minus, so we don't print it. Those we can handle that. We can handle that. Without having an exception, we can handle it. Okay. And the other thing is, okay, so that's this end, right? Like when top is at this end, we cannot pop. And the other end, if top is here, right? Top is here, we cannot push. So after that, we cannot push. So then at this end, that situation has to be handled in push. In push method, so let's go to push method. If top is the size, the length of the array, right? Yes, so we can use another variable in that case. Private int max. Max would be size minus 1. Minus 1. Right. If top is max, right? Top is less than, right? We can do this. Right. So when we implement this, so there are several ways, huh? Right? So this is one way. Else, again, we can so here the stack is empty. The stack is empty. Be more clear. So here the stack is full. So we can use like for example, if top is equal to max, so then we can print this one. Otherwise, we can enter this. Right? But previous implementation is better than that. Right. If top is less than max, so then only we can insert, otherwise stack is full. Suppose let's check that. Right. So now it will be okay. Yeah, no errors. But if I put another, so okay. Stack is full. See, stack is full. So again, I'm trying to insert a new one. Stack is full. Not insert. No exceptions are given. So there's a question here. There's a question. So if we pop until top is -2. After that, if we push, what would happen? So that means again we pop at this point. But the thing is, right, it is not allowed, right? If we are popping the -1, if we are trying to pop the -1, like now the top is here, top is here, now top is -1. If we are trying to pop that, it will give an exception. The program would be stopped at that point. So that means it won't happen here. That pop operation won't happen. So then if you pop to the next one, it does not have any meaning, right? We cannot pop -2. Program would be stopped there with the exception. But in our implementation, right, it won't give the exception, but it will give error message. So the person who's going to use that, so he or she knows that, so the arrays, so the stack is empty. Right. So those things, those additional things have not been added in this. And then additionally, I have added two methods here to check whether array is empty. And then to arrays to check whether array is full. Right. So that's also possible, right? I can add a new method. Boolean. We can return Boolean is full. Whether array is full. So return array full කියලා check කරන්නේ කොහොමද? If top is equal to max. So return this. Sorry. This. Will return the output of this one would be true if these are equal. Otherwise, the output of this would be false. මෙන්න මේ check කරන එකේ result එක true වෙනවා මේ දෙක සමාන වුණොත්. එහෙම වුණොත් මේක return කරන්නේ true. Otherwise it will be false. Right? Similarly, we can is empty if top equals -1, it is empty. Right. So we can use these methods: is full, is empty here. If is empty, if is empty, I put not there. Push here is not sorry, is full. Call the method and we put not. It's not we can check the other way, like without putting note. So we can put this there, and then else we can do this. So that's also possible. Right. So any questions? Any questions from this implementation? Right. So today, so I'm going to finish at that point, at this point. Right. So next week, so I'm going to start from where we stopped, right? And then I'm going to complete this one, and then queues. It is easy again, like queues. So I will explain the concept, and then implementation would be easier, right? If you have the understanding of our implementation of this. Right. So using this stack, we can do different things. So here, one example is given. Two examples are given. Right. Reversing a word. How to reverse a word? Right. If user input a word, for example, my name. I insert my name, and then I insert this into the program, then program would return the reverse of that, right? From here, reverse. So that can be done easily with stack. So if you have a stack, that can be done easily. So an example is given. And then delimiter matrix. That's another example of using stacks. Right? So you can check them. So I'll explain next week, and then we can move into queues. and then we can talk about operations, and then the implementation and some priority queues, special case of queues. Sample program, and that's all, right? Okay, so this note has been shared. So download and check the note, right? So any questions? If you have any questions regarding the things that we have discussed today. So I hope it is clear. So the idea is very simple. Stack. The idea is very simple. The idea is abstract. So then we implement that. This is our implementation. Anybody, so anyone who's looking at this, right? So we have stack class. So we are using that stack class. So that person does not know it is actual implementation inside. Push කියන එක කොහොමද ලියලා තියෙන්නේ කියලා එයා දන්නේ නැහැ. Right? From here, we don't know. Actually, this stack has been implemented using array. The array එකක් මේකේ පාවිච්චි කරලා තියෙනවා කියලා මෙතනදී පේන්නේ නැහැ. Right? When we are using that, we don't care what has been used, what primary data structure has been used. It doesn't matter. As long as we can push and we can poke values. We can push into the stack, and if we can pop from the stack, so that's all. Okay. So if you don't have questions, so I can stop the lecture because I took exceptionally long time to explain this implementation, right? Because if you properly understand this, it will be easier when we are talking about queue. And later on, other data structures. So when we implement a data structure, what we do is we try to implement the operations. We check the operations, main operations, and then so additionally we can add some other operations which could be useful. Okay, right. So that's all. If you don't have questions, so let's conclude the lecture. So have a nice week, and so we are going to meet the new year next year. So have a very good new year for all of you. So I hope we could meet physically, and so let's hope we could have physical lectures at least in the next year. So happy new year. See you on next Wednesday.